Does anyone know what day of the week it is? It is May 2nd, also known as Tuesday, and it is May the 2nd, which means here's the great news. There are 36 days left of school before summer vacation. 36 days left, and only 4 days until May the 4th. That is just, yeah, it's with including school days or including PDA. So 36 class days left. So you only have 36 math class left till the end of the year. That's how you can look at it. We're starting here at 9.2, which is one-step inequalities, which when you factor in the fact that you already have lots of experience with one-step equalities or algebraic equations, these aren't very difficult questions. They're the same thing except just involve a little bit more process, but easy peasy lemon squeezy. Question 3 says, what process would you use to solve the inequality negative 15x is less than or equal to negative 90? Well, there are two things I would do. There are two things. The first thing I would do is divide both sides of the inequality by negative 15. So I would look like this, and it would look like this. The second thing I would do is because I multiplied or divide by a negative value, Will, what should you do if you do that? Yeah, you need to flip the inequality sign. And it's only for multiplying and dividing if you multiply or divide both sides by negative values. So therefore x, you would flip your sign. And how many 15s are there in 90? There are 6 of them. Is that right? So all values greater than or equal to negative 6 is your solution to the inequality. Question 5 says just solve them. So for the first one, A, x minus 7 is greater than or equal to 22. To solve it, I would add 7 to both sides. That's x, all values greater than or equal to 29 is the solution. For B, how do I read this? How do I read that? Do I say 4 is less than x plus 11? I could. What's a better way to read it? Read it backwards on the side of your variable. So x plus 11 is greater than 4, correct? To isolate, I'm going to subtract 11 from both sides. All values greater than negative 7 is your solution. Don't know why they didn't pick up the red, but whatever. Next question, C. 8.6 plus x is greater than negative 5.2. To solve it, I'm going to subtract 8.6 from both sides. And all values greater than negative 13.8 is my solution. And finally, the last one, all values plus, or x plus 65, not 64, 65, x plus 65 is greater than or equal to 100. I'm going to subtract 65 from both sides. And all values greater than or equal to 35 is my solution. Or if you're reading it backwards, 35 is less than or equal to the values of x. Both are appropriate. Question 7 says solve the inequality. Here we have fractional coefficients. I'll see if I can do it here actually on the question itself. I'm going to multiply both sides by 5. And x will be greater than 150. Notice I didn't flip the sign because multiplying doesn't flip the sign. Multiplying by a negative value flips the sign. In the second question, x divided by negative 4, I'm going to multiply both sides by negative 4. Because I multiplied by negative 4, I am going to flip the inequality sign and have my solution of any value less than or equal to 36. Here I'm going to multiply both sides by 1.2. And any value less than or equal to 2.4 is your solution. And finally, I'm going to multiply by negative 1/6, or sorry, divide by negative 1/6. Oops, daisy. Divide by negative 1/6. Does anyone know what dividing by a sixth or a negative 6 is the same thing as? You want to multiply by the reciprocal, correct? If I say divide both sides by negative 1/6, you understand that part gets rid of the multiply by negative 1/6, correct? But let's just think for a second clearly. How would you divide by a fraction if you were doing this? You would actually change it to multiplying by the reciprocal, correct? Does everyone agree with that? Yeah? So therefore, all values. Now, do I have to flip my inequality sign? Yes, because I divided or multiplied by a negative value. My solution would be any value greater than negative 30. Moving on to question 8, says, look at the following operations. For each one, does the inequality symbol need to be reversed when the operation is performed? So if you subtract 5 from both sides, does it need to be flipped? No. When you multiply by 6? No. When you add negative 15? No. When you divide by negative 3? Yes, because multiplying or dividing by negative values causes the inequality sign to be flipped. Multiplying by this number, negative whatever, yes. Multiplying by a negative does require flipping. And dividing by 0.3, no, because it's a positive, not a negative. No, 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 yes, yes, no. Question 9 says, verify whether the specific solution is correct for each inequality. So here is your inequality, and here is your solution. I should do that in green, shouldn't I? There's your solution. Verify that your solution is correct. So there's 2 ways you can do it. Method number 1 is just simply solve your inequality. Right? Solve your inequality. And then check. Is 12, the value 12, less than or equal to 12 and a half? So can x be 12? In this inequality right here, is 12 one of those possible numbers in the set of numbers? Yes. So therefore, x can be 12. Good question by an intelligent young man called Maito. He says, why are we using a semicolon there? The answer is it's the only way we can separate the inequality from this potential solution. Question B, our inequality is this, and our solution is this. Now, in the first one, I actually solved it and then said, another way you could do it, if you wanted to, is you could take your inequality and simply substitute 8 for your x. Substitute 8 for your x. That's a second way to do it, right? And if you substitute 8 for your x, does this work? Is 24 greater than or equal to 21? Yes. So therefore, x being 8 is a potential solution of all the infinite numbers x can be to make this expression greater than 21. 8 is one of those numbers. In our third one, C, let's do the solving at first. So negative 4x is less than 20. In this example, I'm going to solve it. I'm going to solve it by dividing both sides by negative 4. Now, because I multiplied or divided both sides by a negative value, I have to flip that inequality sign. And my solution will be any number that is greater than negative 5. Is negative 3 one of those numbers that is greater than negative 5? Yes, it is. So therefore, one of the values x could be is negative 3. So yes, this is a correct solution. Yes, this is a correct solution. Yes, that is a correct solution. And finally, the last one, negative 1/5 x is less than or equal to 3. This time I'm going to substitute my negative 20 in. I'm going to do it a different way. So negative 1/5 of negative 20 is less than or equal to 3. What's 1/5 of 20? Does anyone know off the top of their head? It is 4. From an algorithm standpoint, or from a how do I solve this on pen and paper, 1/5 multiplied by 20, right, will be 20 over 5, or just 4. Will it be a positive 4 or a negative 4? Right, because a negative times a negative is a positive. So is 4 less than or equal to 3? It's not true, is it? Because 4 is a value that's not greater than or less than 3, so it's not a value. Now, if I go back just to see if it is, and just solve it normally, solve it without substitution, the negative 1/5 x is less than or equal to 3. I'm going to multiply, or I'm going to divide both sides by negative 1/5, and dividing by negative 1/5 is the same thing as multiplying by the reciprocal, correct? And what's the reciprocal of negative 1/5? Negative 5, correct? So I'm going to multiply this side by negative 5. And x is any value that's less than or equal to negative 15. Did I make a mistake? because I think I did. What's my mistake? I forgot to flip the sign because I multiplied by a negative value, so I have to flip that inequality sign. And any value that's greater than or equal to negative 15. Is negative 20 greater than negative 15? No, because negative numbers get bigger as the closer to 0 they get. So therefore, it's still no. Question 11, show whether x less than negative 4 is a solution for each inequality. So I can do it either way. I'm going to solve it. So in the first one, negative 3x is greater than negative 12. Divide by negative 3. Because I divided, I have to flip my sign. Is that the correct solution? Yes, it is. So the value of any value of x less than 4 is your solution for the first one. For b, I'm going to subtract 10 from both sides. X is greater than 4. Is that the same solution? No, because my inequality sign is backwards. So no, that is not the correct solution for b. For c, I'm going to multiply both sides by 4 to isolate. Here's a trick question. Is this and this the same thing? Well, let's read it here. How do I read this? X is less than 4. Let's read it backwards. How do I read this? X is less than 4. Is it the same thing? Yes, it is. So there, ladies and gentlemen, is a great test question. Is this x is less than 4 the same thing as 4 is greater than x? Are those the same thing? Yes. Wonderful question. And finally, your last one, D. What's the coefficient in negative x? So I'm going to divide both sides by negative 1, correct? If I divide by negative 1, I have to flip my sign. Is that the correct solution? Is that the same one? Are you sure, Maito? Are you sure it's not the same? It is the same. So D is the same. So it's yes, x is less than 4 is the correct solution for A, C, and D, but not for B. Question 12 says, verify that the solution on each number line is correct. So if I interpret this solution, what does the number line say? It says all values greater than 4, doesn't it? Is it including 4 or not including 4? Because it's open boundary, it's not including. So that is what the number line says. So if I solve this, I do get this solution. So therefore, yes, the number line is correct with its solution. If I interpret this number line, it says all values greater than 16, correct, but not including 16 because it's an open boundary. Solve my inequality, multiply both sides by 5. It says negative 15 is negative 16. All values greater than 16. Is that the same thing? No, because this is a negative and this is a positive, so the answer is no. The number line is not the solution to that inequality. Question 14 says the Super Fencing Company, which sounds like a made-up name, builds cedar fences for homes that cost $85 per section of fence, including tax. How many sections of fence would you need to buy if you could spend no more than $1,400? So just so we're aware, a section of fence would be like a post and then some runners and another post, and that would be a section of fence, cedar fencing. So each of those costs $85. So the first thing we want to do is we want to say x equals the number of sections. Define what our variable is going to be. Now we could use S for sections or we could use F for fences, doesn't matter. So if it's $85 per, it's going to be $85 multiplied by the number of sections. And this amount can be no more than $1,400. Can it be $1,400? Yes, it can, but it can't be more than that. So this amount, you can have less than or equal to $1,400. So the inequality we would be using is that cost, the cost here, multiplying $85 by the number of sections, can be equal to or less than $1,400, but it can't be more than that. Okay? So once we've solved that, we're going to divide both sides by our coefficient of 85. Don't flip the sign because it's a positive value. $1,400 divided by $85 per. Now, here's a good question. Since they don't sell partial fence things, do I buy 17 of them or do I buy 16 of them? 16 of them is correct. You can buy 16 of them, or you can buy less than 16 of them for your $1,400, but you can't buy more than it. What kind of boundary point will we be using if we use the exact? Closed, but in this case, we are actually going to use 16, 15, and 17. Closed boundary point, and anything less would be our solution. I did forget to write a sentence. Therefore, you could buy 16 or less sections of fence. Sections of fence. Whatever. Yeah, it's expensive. Actually, yeah. Question 15 is a very slender photo of Megan competing in a series of mountain bike races this season. She gets 6 points for each race she wins. If she gets more than 50 points in total, she will move up the next racing category. How many race wins this season will allow her to move up? So right now, how many race wins means that X is going to be number of race wins. How much does she get for each of those race wins? 6 points, right? So therefore, my expression will be 6 multiplied by the number of wins. That's how many points she gets. She needs more than that, more than 50, right? This value has to be greater than 50 in order for her to move up in the standings. Can it be equal to 50? No, it has to be more than 50. Solve it through division of the coefficient. Divide both sides by 6. And X will have to be greater than 50 divided by 6. Now here's a decimal. If she gets 8 wins, will she have enough? No. So 8.8 1/3 wins, or 8.3 repeating is how many wins she needs, which means how many wins does she really need? Yeah. Therefore, she will need at least 9 wins to move up. And if I was actually plotting it on a number line, the actual solution, I'd have to go 8 1/3, 8, 8 2/3, and it would have to be an open boundary point, and this way, correct? Because you can't have 8 1/3 wins. But does that number line make sense? No, because this is not one of the values, and this is not one of the values for wins. So therefore, it is unreasonable for us to use a number line to represent how many wins she needs. And this is not a reasonable value for wins because you can't have a partial win, correct? So therefore, we need to use our deduction and say that 9 would be the minimum, the first whole number on that number line that is valid. Question 16, for each of the following inequalities, state 3 values that are specific solutions. So I'm just going to solve it, adding 5 to both sides. X is less than -5. Any value less than -5. So in our solution of numbers, any value less than -5, -6, -7, and -8. Those are 3 of the most reasonable whole number integers that you could use for your solution. Dividing by -3 and dividing by -3, because I multiplied or divide by a negative number, must flip the sign. Any value greater than -8, 3 values that are greater than -8 are -7, -6, and -5. Those are solutions. Solutions that are not valid. Not valid would be, I forgot to go the reverse way. Forget the reverse way. You all know valid. Numbers that are not valid. Question 17, Colin's teacher asked him to solve the inequality negative 5x is greater than or equal to 15. His solution was x is less than 3. He explained that he reversed the inequality symbol because the negative number. What's a better explanation? Well, the better explanation is just because something's negative. So for example, just because this is a negative number and I add 2 to both sides does not mean I flip the inequality sign. It's only when you multiply or divide by a negative value that you must flip the inequality sign. So just because a number is negative does not mean you flip the sign. It's only when you multiply or divide both sides by a negative value that you flip the sign. Question 19, the owner of a craft store donates 3% or 3/100ths or 3%. Those are all versions of 3%. Of her profits to a local charity each month. So if she wants to donate at least $250 this month, how much profit does the business need to earn? So X will be the profit the business must earn, the profit. How much of this X profit is she going to give? 3%. So let's look at 3%. Do you think my coefficient will be this, will be this, or will be this? Yeah. So given the fact that all three of them are the same thing, correct? Which way do I want to represent 3% of the profit? Probably the decimal coefficient. Agreed? We could do fractions, no problem. We've never done this before. It's bizarre looking and probably the most inappropriate. So I'm going to say 3% of all the profit has to be at least $250, has to be at least or equal to $250. This amount has to be equal to or greater than the $250. So that's the inequality as a inequality statement. Solve it by dividing both sides by 3%. And any value that's greater than or equal to 250 divided by 0.03, $8,333.33, roughly. So any profit that is greater than or equal to $8,333.33 will allow them to donate at least $250 to charity, because 3% of this is equal to $250.